Yes, hello. We want to continue with examples on the alpha and beta. So let's look at this question. If 2x squared plus 6x plus 3 equals 0, then find the sum of roots and the product of roots. And also find the value of the following. So we have A, B, C, and D. So right from the equation that was given, 2x squared plus 6x plus 3, from there, our alpha plus beta will be -3, because what we'll do over here is that we shall divide through this by 2 so that the coefficient here will be unity. And there will be 3 here, there will be 3 on 2 there. So the sum of roots will be -3, and then the product of roots will be 3 on 2. So we take note of that. So alpha beta, that is alpha plus beta is -3, the sum of roots. Then the alpha beta product of roots is 3 and 2. From there, we now want to do question A. So 1 on alpha plus 1 on beta, we simplify it this way. So the LCM is alpha beta. So alpha into this gives us beta. Beta times 1 is beta. Beta into this gives us alpha. Alpha times 1 gives us that. So we have beta plus alpha, which is the same as alpha plus beta because addition is commutative. And from there, we have our alpha plus beta giving us -3. So we have it on top here. Then the alpha beta gives us 3 on 2. We take our time and simplify. We multiply the numerator by 2, the denominator by 2. We shall get -6 on 3. And that finally gives us -2. Right. From there, we move on to B. 1 on alpha beta. So we have 1 on 3 on 2 because the product of roots is 3 on 2. So we multiply this by 2. So 2 times 1 gives us 2. We multiply this by 2. So we get 3 on 2 times 2 giving us 3. So we get 2 on 3. Now let's move on to C. We want to find the value of alpha squared plus beta squared. So we shall use this expression to do that. So starting with this alpha plus beta all squared, we shall get alpha squared plus 2 alpha beta plus beta squared. And this is from the binomial expansion. You can use the Pascal triangle with the coefficients 1, 2, 1. You can take your time and write this 2 times and expand them. Now, from here, let us try and keep alpha squared and beta squared on this side and subtract 2 alpha beta from both sides. So when we do that, it takes us to this step. So we get alpha plus beta all squared minus 2 alpha beta, and that will be equal to alpha squared plus beta squared. So we said that alpha squared plus beta squared will be equal to alpha plus beta all squared minus 2 alpha beta. Now we have the values of alpha plus beta, which is the sum of roots, then alpha beta, the product of roots. And the sum of roots is -3, so we square. Then the product of roots is 3 on 2. So -3 squared will give us +9. Then 2 times 3 on 2 give us 3. So 9 minus 3 will give us 6. So the value of alpha squared plus beta squared is 6. We'll move on to D. D is alpha cubed plus beta cubed. So we do the same thing. We start from here, alpha plus beta cubed. Then we use a binomial expansion to find the value. So this becomes alpha cubed plus 3 alpha squared beta plus 3 alpha beta squared plus beta cubed. Now from here, we want to keep the alpha cubed and then the beta cubed on one side. Then from there, we can also simplify this line this way by doing some factorizations over here. So we get 3 alpha beta, alpha plus beta, which is that same thing. Now the next step is that we want to try and then write it in such a way that we shall get our alpha cubed plus beta cubed on one side. So we subtract the whole of this from both sides. So that will take us to this point. So we see that I have our alpha cubed plus beta cubed. Now from there, our alpha cubed plus beta cubed is equal to the whole of this expression. But we have the values for sum of root and then the product of root and the sum of root. So we do the substitution. So alpha plus beta is -3, alpha beta is 3 on 2, alpha plus beta is -3. Then we simplify it. -3 cubed will give us -27. Then when we come here, 3 times 3 times 3, remember the negative, so we get +27 on 2. Then when we simplify using fractions, we shall get negative 27 on 2. Fantastic. So that does it for these aspects. Try your hands on a number of them. We shall meet again and try our hands. So this will be the question that we shall be looking at in the next tutorial or lecture. Thank you so very much for your time. Bye for now.